We now continue with our final part of this particular unit, which is going to be on the risk measures around portfolio. And we'll try and now incorporate the risk in some sort of return calculations while looking at any kind of portfolio management data. Right? Let's explain the understanding on this one. So what we are saying is we are trying to kind of arrive at some number. Let's start with a simple question, like consider two portfolios. Portfolio 1 giving a return of 32% in first year in a year, while portfolio 2 giving a return of 22%. Which one is better? Now, when you look at a question like this, the first answer that would come to your mind is probably portfolio 1 is better. And that's what most people will choose in general as to what is the correct answer to that, right? But in reality, this is an incorrect assessment unless we have looked at what was the risk that was taken in order to achieve those returns. What if portfolio 1 was a very concentrated one? What if portfolio 1 had 20% weightage to a single stock? What if that bet went wrong? Right? So if that stock that had huge weightage in the portfolio had not gone up and had gone down instead, this 32% could very well have been 12% for all you know. So unless we know what is the extent of risk taken in the portfolio, unless we know what is the risk to return sort of ratio that we're looking at, or the relationship between these two, we cannot say which portfolio is better. In order to say which portfolio has performed better, we need, in addition to the returns, we need to understand what is the risk that was entailed in that, right? And the relationship between risk and return from an investment perspective is direct one, right? If you are investing in a high risk investment, it's expected that you will be compensated by higher returns, right? So if two funds have given 20% return each, but one has taken higher risk than the other, then you don't like that, because if you've taken higher risk, you would ideally want a higher return as well, right? Risk adjusted return relates the return from an investment to the risk taken, and it tries to kind of generate the return from the crux of what was the risk taken there, right? It indicates that the investment was able to generate a higher return for the risk taken or not. Two of the most commonly used metrics are Sharpe ratio and Treynor ratio. These are the two commonly used ratios to measure this. The return number used in the calculation for risk-adjusted return is essentially the excess return. How do you calculate the excess return? Excess of the investment return over generally the risk-free return, right? We will probably discuss risk-free return in some other course at some point of time, but essentially your excess return is the return that you have generated on the portfolio minus what you could have generated using just the risk-free instrument. That's the return for which you should have taken any risk, right? This is the excess return over and above a risk-free rate of return. You will make risk-free rate of return without taking any risk, right? And typically the risk-free return is government bond return in the local currency, right? Domestic currency. Now you will try and compare this to the amount of risk taken. So let's take these one by one. Let's take the Sharpe ratio first, and then we will look at the Treynor ratio. So what does Sharpe ratio say? It says that you have a portfolio return and you have a risk-free rate. That's the excess return you have generated. To generate this excess return, you would have taken some risk. Risk, we have already seen, is kind of specified as standard deviation in the context of finance. So standard deviation of the portfolio is the risk you have taken in order to generate this excess return. So what you are trying to find out is what is the excess return you have generated per unit of risk taken, right? And obviously you're looking at a scenario that higher the better, right? So the Sharpe ratio, it gives you the expected or the actual return, it calculates the expected or actual return on the investment. It subtracts the risk-free investment's return from the expected or actual return and then divides that number by the standard deviation for